This video in the PM1 course covers solving inequalities. This is an inequality. It contains a symbol like this, which means greater than. There are three other symbols, three other inequality symbols. We have less than, like that, and greater than or equal to, which we write like that, and less than or equal to, which we write like that. Now, what we're going to do is solve inequalities. When we solve an equation, for instance, x squared minus 4 equals 0, we are finding the values of x for which that is true. And in this case, we might factorize it, x minus 2, x plus 2 equals 0, and we say an expression can only equal 0 if when they're multiplied together, two things multiplied together, if when one or other is 0. So either x minus 2 is 0, or x plus 2 is 0, or x equals 2, or x equals minus 2. And those are the only two values of x for which x squared minus 4 equals 0 is true. For an inequality such as x plus 5 is greater than 8, we're trying to do the same thing. We are trying to find the values of x for which x plus 5 is greater than 8. And we do similar things that we might do with equations. We rearrange them. So in this case, we're going to subtract 5 from both sides of this inequality. X plus 5 minus 5 is just x. X is greater than minus 8. So x is greater than 3. Now, unlike the equation, when there were two discrete values only, for which x squared minus 4 equals 0, we just had x equals 2 or x equals minus 2 here. Here we have a whole, for the inequality, we have a whole range of values. And sometimes we like to illustrate that on a number line. So here's a number line, x greater than 3, it's over here, so I draw that as a line going towards the right, and it's not equal to 3, so I'll illustrate that by drawing a circle at 3, showing that I don't want to include 3. Now, the usual rules of algebra and arithmetic for equations don't quite apply. For instance, we have 5 greater than 3. We can add a number to both sides, so we add 2 to both sides, and it remains true. So we add 2, 5 plus 2 is greater than 3 plus 2. That's still true. 7 is greater than 5. We could subtract a number from both sides. 5 minus 2 is in fact greater than 3 minus 2. 3 is greater than 1. True. If we multiply by 2, that's by plus 2, we have 5 times 2 is in fact greater than 3 times 2. 10 is greater than 6, still true. But what happens if we multiply by minus 2? We'll see 5 times minus 2, which is minus 10, and we'll have 3 times minus 2, which is minus 6. And minus 10 is not greater than minus 6, it's less than minus. So the symbol is reversed, and that so that we have minus 10 is less than minus 6. And so when you multiply or divide by a negative number, you have to change the inequality to the from less than to greater than, or from greater than to less than, as in this case. You normally have to simplify an expression before you can solve an inequality, or to solve an equality. Look at this one here. Find the range of values of x for which 2x minus 3 times 2x plus 4 is less than 0. So we would simplify the left hand side, expand the bracket, 2x minus 6x minus 3 times 4 is minus 12 is less than 0. We have minus 4x, 2x minus 6x minus 12 is less than 0, and then I can add 12 to both sides. Minus 4x is less than 12, and now I'm going to divide by minus 4. So that was adding 12 to both sides. This is dividing by minus 4, and because I'm going to divide by a negative number, I have to reverse the sign, the inequality sign. So divided by minus 4, we'd have x, and then reversing is greater than minus 3. So that would be the solution, the range of values of that inequality. Now here's one for you to practice. When you've done it, stop the video and solve this inequality, and when you've done it, resume the video and to see the solution. Now, just like an equation, we collect the x terms on one side and the numbers on the other side. So let's subtract 2x from both sides. I'll have x minus 2x is greater than minus 4, and then add 3 to both sides. We have subtract 2x, add 3. We have x minus 2x is greater than or equal to 3 minus 4. X minus 2x is of course minus x. 3 minus 4 is of course minus 1. So now we have to multiply both sides by minus 1, and so we must reverse the inequality to get x is less than or equal to 1. And that's the solution. Now let's consider quadratic inequalities. Supposing we have x squared minus 2x is greater than 3. This is a quadratic as it has an x squared term in it. Well, like a quadratic equation, we'll rearrange it so that we have 0 on the right hand side. So subtracting 3, x squared minus 2x minus 3 is greater than 0. We can factorize it. The factors of this are x plus 1, x minus 3 is greater than 0. So we have two things multiplied together greater than 0. Now, this is not an equation. We can't say, like for an equation, if it was equal 0, we would say x equals 1 or x equals 3. That's because if two things are multiplied together to get 0, one or other of them must be 0. This is not true of inequalities. In fact, what we have here is two things multiplied together must be positive. In this case, either both must be positive or both must be negative. And there's several ways you can use to find this, to find the range for which that's true. A simple way is to draw a graph. So let's sketch a graph of x squared minus 2x minus 3. Having factorized it, we can see that the graph crosses the x-axis, or the curve crosses the x-axis when x is minus 1 and when x is plus 3. So minus 1 and 3. It's a quadratic, so it has a shape looking like this, or this, or this. And because it's positive x squared, we have this shape, like a U, rather than this shape. We can also see it goes on the y-axis, it would pass through minus 3, because that's when x is 0, so that'd be down here. And so the curve would look like this. Now, having drawn the curve, we can see where this graph is greater than 0 and where it's less than 0. It's greater than 0 where it is above the x-axis, where we have y is positive, and less than 0 below the x-axis, where the function is negative. So we want where it is positive, greater than 0, which is here and here. And so x can be, the x values are less than minus 1 here, or greater than 3 here. And we write that by saying x is less than minus 1, or x is greater than 3, like this. Sometimes you might have two inequalities to solve, like this. We have a quadratic inequality, x squared minus 2x minus 3 is less than 0, and a linear inequality, 2x plus 3 is less than or equal to 5. Now the first inequality, the quadratic, x squared minus 2x minus 3 is less than 0, is the same as before. X plus 1 minus x minus 3 less than 0, except we have less than 0 instead of greater than 0. And we can, again, to solve that, we sketch the curve. And this time, because we have less than 0, the part of the curve which is less than 0 below the x-axis is here. It's between minus 1 and 3, when x takes a value between minus 1 and 3. And the way we write that is in one statement, x must be greater than minus 1 and less than 3. So when it's between two values, we can write it as one statement. When there are two separate values, as we had before, x less than minus 1, x greater than 3, we write as two statements. So the second inequality is 2x plus 3 is less than or equal to 5. So we subtract 3 from both sides, which will give us 2x is less than or equal to 5 minus 3. Or 2x is less than or equal to 2, and dividing by 2 we have 2 less than or equal to 1. So we now have two inequalities which must be satisfied. From the first one, x is less than 3 and greater than minus 1, and from the second inequality, x is less than or equal to 1. And the solution of both inequalities together is the range of values of x which for which both of these ranges are true. And the best way of finding that range is to use the number line again. So for the first one, x lies between minus 1 and 3. We illustrate in this way. Minus 1, minus 1 is here, 3 is here, And because minus 1 and 3 are not included, we put circles there. And for the other one, x is less than or equal to 1, then that would be all the way along to here, and then including 1, and we'll illustrate that with a solid circle. So open circles when the end point is not included, and a closed circle when it is. And then simply the values of x which satisfy both inequalities are where both lines, we have both lines. So it's between minus 1 and plus 1, which is where both lines are present. It includes the plus 1, but it doesn't include the minus 1, because minus 1, although it's included in the second range, x is less than or equal to 1, it's not in the first range, and therefore is not in both. So the solution of both inequalities together then are x is greater than minus 1 and less than or equal to plus 1. Now pause the video and try this problem for yourself. When you've done it, resume and I'll show you how it's done. Okay, so the first inequality, 2x squared minus 9x plus 9 greater than 0, we can factorise the quadratic. 2x and x and 3 and 3 will give us 6x and 3x. Subtract both like that, and that is and those are the factors. And so if we were to sketch that curve, we can see that the curve crosses the x-axis when x is 3 over 2, and also when x is 3. And so the curve looks something like this. And so we want the values for x for which the quadratic is positive, and so that is over here and over here, corresponding to the portion of the curve which is above the x-axis. And so that is x is less than 3 over 2 and x is greater than 3. Second inequality, 2x plus 3 is less than or equal to x plus 1. Subtracting x from both sides and subtracting 3 from both sides gives us x is less than or equal to minus 2. So the two ranges that must be both satisfied are x less than 3 over 2, 1.5, x greater than 3, and x is less than minus 2. Using the number line again, the first range, x less than 3 over 2, 3 over 2 is about here. Now we're not including 3 over 2, so that is an open circle. Whoops, that's wrong. So about here, 1.5, and so that range is represented by that. And x greater than 3, 3 is here, and so that's represented by that. The second inequality, x is less than or equal to minus 2. Minus 2 is down here, but it includes minus 2, so a solid circle and less than minus 2 is like that. And so we see that now that the only part which for which both lines are present is less than or equal to -2. Equal to because we have a solid circle. So that is only to the left of that red dotted line, which is x less than or equal to -2. Okay, that is the end of this video on inequalities. Please now return to Study Smart to practice.